Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by sensing input, capacitive touch, pressure sensors, or IMU motion. The hardware converts analog signals into digital events via ADC and sampling. This ensures timing accuracy. Once the event is captured, you map it to a haptic profile, intensity, duration, and waveform inside firmware or the OS. Make sure to sample at sufficient rate to avoid latency. Lower latency gives crisper feedback. Now that your event is mapped, proceed to drive generation and actuator selection in the next step. You choose the actuator based on fidelity needs. Eccentric motors for simple rumbles, linear resonant actuators for sharper pulses, or piezo for high-frequency clicks. Then you convert the haptic profile into an electrical waveform using PWM, DAC, or dedicated haptic driver chips. Closed-loop control can adjust output in real time. Once driven, frequency and amplitude determine perceived strength and texture, while the envelope shapes onset and decay. Make sure to balance power and thermal limits as you implement the waveform. You finalize by integrating haptics into the system. Synchronize vibrations with sound and visuals, and account for input latency so sensations feel immediate. Tune parameters per device. Different actuators need different amplitude and frequency adjustments, while monitoring power draw and thermal behavior to avoid throttling. Once done, test across scenarios and user profiles to refine perception. If things go wrong, check drivers, wiring, and timing first. Intermittent or weak output usually points to software timing or.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.